Hey guys, what's up? I hope everybody's doing well. I hope that you're all staying safe and you're all staying, in your homes and doing all of your fun stuff. I know that I am. Like, granted, it's starting to get a little boring. Don't get me wrong, I still play a lot of video games. I've been hanging out with V and stuff, but it's still starting to get a little crazy. So, I wanted to get with you guys and give you guys a new lesson today. I want to keep going on plate tectonics. Okay, but listen, let's recap just a little bit about what we have already talked about and what we talked about in the last lesson. So in the last lesson, we talked about Alfred Wegener. Who was Alfred Wegener? Wegener was this guy that came up with this theory of continental drift. He said that the continents, we were all one big continent, one big supercontinent called Pangaea. Okay, and he was the one that came out and said, "Hey, we used to be together, and this big supercontinent, and here's why." And so he basically said, "Okay, there was four clues that he gave, four basically different types of evidence." All right, and so his first one was that we all fit together like a puzzle, and it was like, okay, well, we can all look at that and say, hey, okay, yes, it looks like that we used to fit together like a puzzle. Number two, he came out with like rock evidence, okay, and like there were same types of rock mountain ranges in Europe as there was in North America, okay, and that was a little iffy, okay. So then he came out and he said, well, there's fossils too, so why is this fossil here and this fossil here? Like, these things didn't swim across oceans, okay. So that was number three. And then number four, he had these climate things, okay, the reasons why there were glaciers in the middle of Africa, glacier evidence in the middle of Africa, okay, and stuff like that. So he had all this evidence, but he didn't have one thing. What did he not have? He did not have proof of why we actually slid apart. Like, we're not floating, these floating land masses on water, so we don't just float around the ocean. We're attached. We're land. Okay, and so this guy named Harry Hess came out with seafloor spreading. They found the mid-Atlantic ridge, and there's this divergent boundary there, and it started spreading apart. And so they came up with seafloor spreading. Okay. And once they came up with seafloor spreading and you put the two together, okay, it didn't sound so hokey then. Okay, you put the two together and you came out with plate tectonics. Now, plate tectonics is what this entire chapter is about, and so we're going to talk more about plate tectonics, and today we're going to talk about boundaries. So you need to know the three different types of boundaries today that we're going to go over, and we're going to go three different types. And we've talked about these guys over time. We talked about this stuff like when we did oceans, but these three boundaries. So we have divergent, we have convergent, and we have transform. Okay, and let's just get right into it. Okay, so plate boundaries. Okay, so these plate boundaries are where this stuff happens. Okay, so these plate boundaries is where you have these convergent boundaries, where you have divergent, where you have transform. This is where earthquakes, this is where volcanoes happen. Okay, you guys know that the San Andreas Fault in California is a transform boundary, and we'll get to that in a few minutes, but it goes side to side, therefore it's going to create earthquakes. Not to mention convergent boundaries create tons and tons of volcanoes. I will show you South America in just a few minutes. Okay, but that's kind of how those go. Okay, but the three types of boundaries, we have divergent, we have convergent, and we have transform. So make sure that you know those. Do not forget it. Divergence going apart. Okay, convergence coming together. Transform is going side to side, like they're moving side to side, just like this. Okay, all right. Now, okay, and here's what they can kind of look like, and you can kind of see with the convergent boundaries we're going to get lots and lots of volcano activity, okay, and mountain ranges, okay. And so as you can see here, now this is like South America, the coast of South America, the western coast of South America, okay, and you can see, like, look at all these red triangles. These are major volcanoes, okay. So look how many of them there are going along this boundary right here. This right here, and you can see it, this is the like out here in the ocean where this dark blue is, okay, that's the convergent boundary, and this is creating all of these volcanoes up and down this mountain range. And if you guys don't know, this is a massive mountain range in South America, Argentina, okay, Argentina, Chile. Whoops, I told you, I never claimed to be good at geography, okay. All right, so let's talk about plate movement with divergent. Divergent is like when it's spreading apart, okay? So we call it spreading centers, the place where two plates can move apart. All right, now, sorry guys, I'm kind of doing both here. All right, so where you have divergent, okay, now where do we know there's a divergent boundary? That's right, in the Mid-Atlantic Ridge. The Mid-Atlantic Ridge, which runs right up the middle of the Atlantic Ocean, is the divergent boundary that comes apart. Now, as it comes apart, this is where seafloor spreading happens, okay? So that lava starts to come up through, the magma starts to come up through, and it creates more and more and more and more and more, and it creates us to kind of move apart, okay? And that's kind of how that works, all right? All right, and so as you can see here, you can see the Mid-Atlantic Ridge going right through here. Here's Florida over here. Okay, if you don't see it. Okay, whoops, I'm going to go back. I just wanted to show you where my mouse was. Okay, and there's the Mid-Atlantic Ridge, and that's seafloor spreading. So over time, over long periods of time, it's created this massive mountain range going through the Atlantic Ocean. Okay, let's talk about Iceland. Now, we talked about this once before. What happens to the Mid-Atlantic Ridge in Iceland? It comes up out of the water. That's right. Remember that it comes up out of the water, and you can actually go and you can see it. Okay, and it actually comes up, and here you can see, like, here's a good picture of the Mid-Atlantic Ridge right there in Iceland. Okay, among other things in Iceland, like, listen, I know that that's really cool that it comes up, but this is a bridge of water over water. Have you ever seen a bridge of water? I mean, I've seen bridges go over water, but I've never seen a water bridge go over water. Okay, it's an interesting picture. I hope that you get it. Okay, also blue lagoons in Iceland. Okay, let's talk about the Great African Rift. Great African Rift is another divergent boundary. It's a divergent boundary in Africa. You can see it. It's over here on the east coast. But, like, it's all where this Red Sea is, Gulf of Aden, Lake Victoria, all down through here. This is this divergent boundary. And this is a massive park. Okay? Massive park. You can kind of see it here, kind of coming down through there. All right, but this is the Great African Rift. Here it is. Like, it's major. Like, much bigger than what you see in Iceland. Okay? All right, so let's keep going. Convergent boundaries. Okay? This is where two plates come together. What does this cause? Volcanoes, mountain ranges, trenches. Okay, Marianas Trench is made by a convergent boundary. You've got one subducting, and it's creating this trench. You see how that works? Okay, deepest place on Earth, Mariana Trench. All right, and these are convergent boundaries. Now, here it is, right off the coast of Japan. The Mariana Trench right here. Okay, and you can kind of see, so here's this convergent boundary. You can see the Pacific plate is actually subducting under the Philippine plate, okay, and creating this Mariana Trench. Okay, now let's talk about a transform fault. Now, a transform fault is what we have at San Andreas. Okay, San Andreas in California is where we have this transform fault where these plates move constantly side to side. Okay, and they just grind past each other. And that's why they experience so many earthquakes in California, okay, is because that they have all of these this active boundary here. As this transform plate just continues to slide side by side like this, okay, it just is constant earthquakes all the time, and you can, like, that's why they always say if something ever happens, California will break off, because there's just this transform fault. But, like, will it? I'm not necessarily. It's a transform fault. They're going side by side. They're not really diverging. I don't see California breaking off in anytime soon. Okay, but now, do they get a lot of earthquakes? Yes, tons. Okay, and here you can kind of see it. Here's the San Andreas Fault running right down here. Runs almost very close right through the middle of San Fran and very close to LA, and that's why San Fran just deals with those earthquakes constantly all the time. Here's a small picture of it. I'm not really sure exactly where this was taken, but there are tons and tons of pictures that you guys can see. Okay, now I love this picture right here. This is a picture that you guys have already seen, that you will continue to see. Okay, but this picture kind of gives you all three boundaries. Here's your transform, Here's your divergent. Here's your convergent right here. You can see the subduction right here. Okay, and here's your convergent boundary right here with this subducting plate over here. You got convergent, so here you have all your volcanoes, mountain ranges. This would be like the coast of South America here. Okay, and then over here you can see a divergent. That's that ocean spreading ridge. And then over here another convergent. Okay, and you're starting to get some island arcs, volcanoes, things like that. Islands are kind of like what can happen from a convergent boundary. Okay, and that kind of works that way. Okay, all right. I'm pretty sure that's where we're stopping today. The next thing that we're going to get into will be actions at plate boundaries, kind of like what happens, like volcanic activity, island arcs, you know, those types of things. Please make sure, guys, that you're watching the videos to the very, very end. They count points off if you don't. All right, so make sure that you are. Granted, I got no reason to really drag this out. You know, I just wanted to give you a quick lesson and keep going through plate boundaries. Okay, so this is your lesson for today and your assignment for today. There'll be a whole new assignment for tomorrow so that we can continue on boundaries and keep going on these things. Again, guys, I hope that you all are well. Please stay well. Get your work done. Okay, I have to have grades in by Friday. Okay, grades by Friday. Friday. Make sure your work is done, guys. Seriously, most of my, like, 2 of my assignments are literally watching a video. One of them is watching a 2.5-minute cartoon. Get it done. Come on, get your work done. I hope you all are well. I will see you next time. Toodaloo.